Hello, today we are looking at section 3.4. This is our third day looking at this section, and we are looking at equivalent linear relations. So we have to date looked at equations in slope-intercept form. Here's slope-intercept form, y equals mx plus b. M is the slope, b is the y-intercept. We've also seen equations presented in standard form. In standard form, I have the x, the y, and the constant all on the left-hand side of the equal sign, and 0 is on the right-hand side. So starting with example 1, we are going to sketch both equations, y equals negative 2x plus 3, and the equation 2x plus y minus 3 equals 0. We're going to sketch each of these using the most appropriate method. So for my first equation, y equals negative 2x plus 3. This equation is in slope-intercept form, so the easiest way to graph this is by identifying first the y-intercept, which is 3, b equals 3, and then identifying my slope. So my slope is negative 2, m equals negative 2, but I actually want to think of my slope as a fraction, so I'm going to rewrite that as negative 2 over 1. So when I go ahead to graph and begin graphing this line, I start with my y-intercept, which is 3. So on my y-axis, go up to 3, mark it with a dot. From this point, I'm going to move according to my slope. My slope is negative 2 over 1. So from my y-intercept, I move down to right 1, draw my second point, and connect my 2 points with a straight line. And here we've drawn the line y equals negative 2x plus 3. Moving on to our second equation, 2x plus y minus 3 equals 0. What I'm going to do here is I'm going to graph using my x and y intercepts. And the reason being, this equation is presented in standard form. So that's the easiest way to graph this line. So recall, to find my x-intercept, what I want to do is plug in 0 for y in my equation and then solve for x. So I have 2x plus 0 minus 3 equals 0. Move the 3 over to the other side. 2x equals 3. Divide both sides by 2, x equals 3 over 2, or if you'd like, you can think of that as a decimal, x equals 1.5. So on my x-axis, I move to the point 1.5, there it is, and I mark it. Repeat this process for my y-intercept. This time I'm plugging in 0 for x. So 2 times 0, all of this becomes 0, plus y minus 3 equals 0. I take that negative 3, move it to the other side, and I have y equals 3. On my y-axis, move up to 3, mark it with a dot, and then connect with a straight line. So when I look at these two lines, these two graphs, what you should notice is that they are identical. So that means that this equation here, y equals negative 2x plus 3, is equivalent to this equation here, 2x plus y minus 3 equals 0. So in fact, every linear equation can have an equation in slope-intercept form, or it can have that same equation rewritten in standard form. So that's what we're going to do. We're going to look at equations in standard form, write them in slope-intercept form, and vice versa. So example 2. We are going to rewrite these equations in slope y-intercept form. So I want them to look like this. Y equals mx plus b. Example A. Y minus 5x plus 6 equals 0. So I want the y all by itself, which means I have to move the negative 5x and I have to move the positive 6 over to the other side. So recall, when I move numbers or variables from one side of an equal sign to the other, what I'm actually doing is the opposite operation to both sides. So for example, for this positive 6, to move it over, what I'm actually doing is I'm subtracting 6 from both sides. That's what actually happens, right? So take this positive 6, move it over, and I end up with y minus 5x equals negative 6. Well, I actually want to move the negative 5x over as well. Well, here it's negative. When I move it over, it becomes positive. So I end up with y equals negative 6 plus 5x. So this is good. Y is isolated. However, I really want to see the x first and the constant second. So I'm actually going to rewrite this as y equals 5x minus 6. And there is my equation presented in slope-intercept form. Again, these are equivalent. If I were to make a table of values, if I were to use slope, if I were to use both my intercepts and graph, I'd end up with the exact same line. Example B. I want to isolate y. I want y all by itself. Well, the 6 is already on the right-hand side. That's good. what I want to do is take this 3x and move it over. So when I move the 3x over, it has to change sign. So positive 3x, when I move it over, it becomes minus 3x. So 2y equals 6 minus 3x. Again, I want to see the x written out first. So I'm going to rewrite that as 2y equals negative 3x plus 6. And then to get rid of this 2, I divide everything by 2. So we end up with y equals negative 3 over 2x plus 3. Example C, there's the y. I want it all by itself. Notice that negative is in front of the 3y. It's attached to it, so I can't get rid of it immediately. Okay, that stays. So the 2x has to move over. It becomes negative 2x. The 3 moves over, and it becomes minus 3. So negative 3y equals 6 minus 2x minus 3. Well, I want to write out the negative 2x first. We always want y equals mx plus b. So negative 2x, and then I've got 6 minus 3 becomes plus 3. So negative 3y equals negative 2x plus 3. I need to get rid of this negative 3. So every term gets divided by negative 3. Be careful here. When I divide, this becomes positive. When I divide, I've got a negative divided by a negative. Again, that's going to become positive. And then I've got positive 3 divided by negative 3. That becomes minus 1. So be careful when you're dividing by a negative, please. So now we're going to do the opposite. I'm going to give you equations that are in slope-intercept form, etc., and we would like to rewrite in standard form. So again, standard form means that we have everything on the left-hand side moved over. We have everything on the left-hand side, my x, my y, and my constant, and on the right-hand side, I have my 0, okay? An extra note here, these numbers, a, b, and c, they can't be fractions. And also, a has to be positive. So those are very specific rules. I'm going to do an example with you, but I don't want you to worry too much about this. We'll explore this more as the course progresses. Okay? So example A, y equals 6 minus 3x. I want everything moved to the left-hand side. So y is already here, that's good. I'm going to take the 6 and move it over, and it becomes y minus 6. And I'm going to take the negative 3x and move it over, and it becomes y minus 6 plus 3x equals 0. So there I have everything on the left, 0 on the right, which is good. But what I want to do now is rewrite the order so that I have x, then y, then the number. So rewrite it, 3x plus y minus 6 equals 0. And there I have my equation that's been now y equals 6 minus 3x. That's been changed to standard form. Again, these are the exact same lines. If I were to graph them, I'd get the same result. Example B, negative 3x equals 1 minus 5y. So the negative 3x is already on the left-hand side. I'm going to move the 1 over, becomes negative 1. Move the negative 5 over, becomes plus 5y, and I'm left with 0 on the right. Now I'm going to rearrange the order. So negative 3x plus 5y minus 1 equals 0. So it looks good, right? I've got x, then y, then the number equals 0. There's a slight problem. See this negative? We're not allowed to have a negative when we have an equation written in standard form. So an easy way to get rid of that negative, since I have an equality here, I'm going to multiply everything by negative 1. And when I do that, my negative 3x becomes positive 3x, positive 5y becomes negative 5y, negative 1 becomes positive 1, and even the 0 gets multiplied by negative 1, but it remains 0. Okay? In my last example here, example C, notice that I have a fraction. Well, it says up here that no fractions are allowed in standard form. So the easiest way to get rid of this fraction is to multiply every single term by the denominator. So everything gets multiplied by 5, and I'm left with 1/5 x times 5, that's x. 2y times 5, that's 10y. 7 times 5 equals 35. So I'm going to take that 35, move it over, and we're left with standard form, x plus 10y minus 35 equals 0. I'm going to turn to page 2. Example 4. Marie works at a boutique and at a travel agency. In all, she works for 40 hours per week. Define variables and write a linear relation to model this case. So I'm going to let B represent the hours that Marie works at the boutique, and I'm going to let T represent the hours that Marie works at the agency. an equation for me, she works in all 40 hours. She works in all, for the entire week, 40 hours. So B, the number of hours at the boutique, plus T, the number of hours at the agency, equals 40. There's my equation. B plus T equals 40. Part B, sketch it. So the easiest way to sketch is to use my intercepts. So my B-intercept, I solve, I get 40. My T-intercept, I solve, and again, I get 40. Notice I'm calling them B and T intercepts instead of X and Y intercepts. That's because I used B and T in my equation. You didn't have to. You could have used X and Y. That's arbitrary. It's up to you. Okay. So instead of labeling this my X-axis, this is called my B-axis, hours worked at the boutique. This is my T-axis, hours worked at the agency. Sorry, I think I shifted this a bit. There we go. Okay, so my B-intercept is 40. I need to mark this. Well, before I can mark it, I need to label my axes, right? So I need to choose an appropriate interval. Since my intercepts are 40, I'm definitely not going to go up by ones, so I've chosen to go up by tens on both axes. So I mark 40 for my B-intercept, mark 40 for my T-intercept, and I connect. Notice I didn't put arrows on these lines. We've talked about this before. I can't go into negative hours worked. It doesn't make any sense. So my line actually starts and stops here. Okay. Put a label, Marie's work week, and here I can see that these are all the possible combinations of hours worked. Part C, what do the X and Y intercepts mean? So in my case, they're B and T intercepts, not X and Y, okay? But for me, my horizontal intercept, that's my B-intercept, okay? What does it mean? Well, the coordinates are 40, 0. It means that Marie has worked 40 hours at the boutique and 0 hours at the agency. My vertical intercept, or my T-intercept, has coordinates 0, 40. And what does that mean? It means that Marie worked 0 hours at the agency, 40 hours at the boutique. Okay, so this is the end of our lesson. I do have for you some additional questions for you to look at. Please take a moment and add these 6 problems to your homework. Okay, homework is on the next page. There's the homework, page 171, number 9, 11, 13, 15, and here are the solutions to the additional 6 problems that I've assigned to you. Okay? All right, so if there are any problems, remember, reach out to me either through Google Classroom or through my K-12 email, and I will respond as quickly as possible. Thank you guys. Have a good day.